Hello guys. The next application that I would like us to look at, applications of integration, is the mean and RMS value. Now, these two are very important, so we'll have to remember them each and every time. So the mean value, which is also abbreviated as Y bar, is given by 1 over B minus A, integral from A to B of y dx, okay? And the RMS value is given by the square root of 1 over b minus a, integral from a to b of y squared dx, where basically y is the value that you've been given, the value of the function, and ba are your limits or your range. Now, let's take up an example here. So we're being told a voltage V is given by 100 sine theta. So basically in this point here, our Y is our V and our theta is basically the value of the X. So we're being told to use integration to determine over half a circle, the mean over half a cycle. So over half a cycle basically means from 0 to pi. Now let's come and get y bar, which is the mean value. Now the mean value is given by 1 over b minus a. So we've said that it is from 0 to pi, meaning our a is 0 and our b is pi. So b minus pi will be pi minus 0. Integral from a to b, that is from 0 to pi of y dx. And what is our y? Our y is v in this case, and it is 100 sine theta, 100 sine of theta d theta. Then basically that's it. We evaluate this and get the mean value. So what will this give? This will give me 1 over pi into integrating 100 sine theta. We will get 100 cos of theta, and then replacing the range from 0 to pi. So this will give, I can write 100 over pi outside. Replacing, I will have cos of pi. Pi is 180 degrees minus cos of 0. So evaluating that correctly in the calculator, I will get my answer to be equal to, so let's see. So actually the integral of this is minus 100 cos theta, because we're integrating sine. So we'll have minus here. Let me just write that correctly. We will have that as, so I can take out minus 100 pi outside. So I'll have minus 100 over pi, then replace the values in cos theta. So I'll have cos of 180 degrees minus cos of 0 degrees. And what will that give? So evaluating cos of 180 minus cos of 0 is obviously 1. So this will give cos of 180 is minus 1. So I'll have minus 1, that will give minus 2. Minus 2 multiplied by minus 100. So that will give 200 over pi, which is the same as 63.66 volts. And that is basically our mean value. That's it. That's how we go about getting our mean value. Then what about getting the RMS? Now RMS is given by the square root of 1 over b minus a. And our b, we've said, is pi in this case, minus a, which is 0. Integral from a to b, our a is 0 to pi of y squared. Our y is 100 sine theta. So y squared will be 100 times 100, which will be 10,000. And then we have there sine squared theta, obviously. So that will be sine squared theta d theta. So evaluating this will give us the RMS value. So we just evaluate the integral and then get the square root, So I want to first of all start with this. I can have the 10,000 outside so that I just integrate, find the integral from 0 to pi of sine squared theta d theta. Okay, now sine squared theta from trigonometry, we know that sine squared theta can also be written as, if we have cos 2 theta, it is equal to 1 minus 2 sine squared theta. So making sine squared theta the subject of the formula, we will have, so sine squared theta, bring it to this other side, I'll have 1 minus cos 2 theta, all this divided by 2. So the same as having a half there. So in order for me to integrate this, I can just rewrite it in its simplified version so that I have it as integral from 0 to pi of a half. So write the half outside of 1 minus cos 2 theta, because evaluating this is easier. So I have a half outside, integrating 1, I get theta, minus integrating cos 2 theta, I have integral, so positive, integral of cos is positive sine. So I will have sine 2 theta, all this divided by 2, and the range is from 0 to pi. Okay, fine. So evaluating that, what do we get as our answer? So coming back here, we have a half into replacing the value of theta, pi minus sine of 2 pi, minus replacing the value of 0, we'll just have 0 minus 0. Okay, so I have a half into pi, because sine of 2 pi is 0. So this basically gives me pi over 2. Okay, let's take it back into the equation here. So we basically had the square root of 1 over pi minus 0. So we have the square root of 1 over pi, and then we have 10,000, because we've already evaluated the integral. So we have 10,000 multiplied by the integral of sine squared theta, which we found to be pi over 2. Pi over 2. Okay, so what does this simplify to? So as we can see, this pi can cancel out with that pi, and then these 2 can cancel out with that, so that whatever we remain with inside the bracket is, or better yet, so whatever we remain with inside the bracket is 5,000. So we are evaluating the square root of 5,000. So if you evaluate that correctly, we should be able to get 70.71 volts, and that's basically the RMS value. That's basically the RMS value. So this basically just entails like following the formula. There's really nothing much about it. Let's just take up another example. So example number 2. So we're being told the vertical height of a missile is given by h is equal to 4d minus d squared. Determine the height of the missile from, so determine the height of the missile from d is equal to 0 to d is equal to 4 kilometers. So let me go over it again. The vertical height hk of a missile is given by h is equal to 4d minus d squared. Determine the mean height. So we want to get the mean height. So the mean height. So basically we want to get the mean. So recall, how do we get the mean? The mean is given by the 1 over b minus a integral from a to b of y dx. So our mean value so our mean value will be given by 1 over b minus a, where b minus a is basically the limit. So here we have 0 to 4. So this is our a, this is our b. So 4 minus 0, integral from 0 to 4 of y dx. And what is our y? Our h, because this is what we are looking for. So 4d minus d squared. And then we are differentiating with respect to D, obviously. So let's have it as DD. So what will this give? 1/4 into integrating with respect to D, that will be 4/2 D squared. So that will be 2D squared minus D cubed over 3. Integral is from 0 to 4. Okay, fine. So evaluating that, we should be able to get the answer. So this gives 1/4 into 2 4 squared minus 4 cubed over 3 minus, if we replace the value of 0, 0 here, we will just get minus 0. So evaluating that correctly, we should be able to get that our mean height is 2/3 kilometers. And that's it for mean and RMS values. That's how we go about those questions.